Okay, cool. I think we're online. Ah, I always wanna let that intro play out, like, the full 10 minutes because it's really fun to dance to.
Oh,
Um
yeah.
Anyways, let's get started. It is episode 9 of, Web3 Unleashed. We're finally down to
Yes.
our front end, of the rental marketplace. Today, we are joined by Chris Anatolio, um, from the Infura team. You wanna give us a brief introduction of yourself?
I mean, that's about it. So, I'm Chris Sanatelio. Yeah, I work on DevRel for Infura. And yeah, I collaborate closely with Emily. And yeah, let's talk about some NFT stuff.
That's so wow, that's so reductive, Chris. You're a full human being. You have hobbies, you have a tattoo on your hand. Um, Not that that's something you introduce, I guess, in a Web3 podcast, but I digress. Yes, so today I brought on Chris because he is the platform advocate for Infura, and with our front end specifically, we are incorporating the Infura NFT API, as well as in using the Infura's IPFS gateway. So Chris, I guess I'm bringing you here as our product expert. Just wanna start
Sure.
with the very basics, assuming you're a beginner, like, what even is Infura?
So,
It's,
yeah.
like, so obvious to us, right? But, like, I think for
Well, yeah. So, no, definitely. So, let's say coming from the perspective of a Web2 developer onboarding to Web3, it's like you want to build your first DM. So, first you need MetaMask, your wallet. Then you need Truffle, your DevTools suite. But now you actually need to talk to the Ethereum blockchain, or you actually need to talk to IPFS. Um, so back in the day, everyone was like, "Hey, we just run your own node. Let's be super decentralized." But one thing that the community has found out over time is it's really difficult to run a Ethereum node at scale. That could handle the traffic of a big DApp with millions of users. Um, and also, like running a node is difficult. It's I don't know the most updated stats, but I think it's like 27 terabytes. Like if you spin up a new node, like a full archive node, like with all the history back to the Genesis block, it takes a month. Like literally,
a
like
month?
yeah, not
Wait,
even
that's
not exaggerating.
insane.
Yeah. So like if you want to start up an Ethereum node and say like give me all the traffic back to the first block ever, it's like, all right, I'll see you next month. You know, it's crazy.
Wow, wow. Okay, that's insane.
Yeah. Yeah.
Um, yeah,
But
I
then
mean, to that note, though, just wanna give a quick shout out to Infura. So for those of you who use Ganache forking, so specifically zero config forking, so something like Ganache fork, like mainnet, right? Um, you can do this because Infura provides free access to an archive node. So you actually don't have to sign up for an account to do forking or anything. That's because Infura did that for us. So, thank you. I didn't realize it was
oh,
that insane. Um,
oh, yeah.
yeah, that's crazy. But cool. Now that we have, like, bird's eye view of, I guess, Infura, I wanna dive into the tools that we're using from Infura today specifically. So, as expected, right, our, like, RPC endpoint that we're connecting to, so that's gonna be Girly, that we're connecting to today. But then now we're also using the NFT SDK and the API. So can you dive into, I guess, those 2 things? Are they different from each other? Are they the same? Um, what is it, and how does it work?
Sure. Yeah, so just to talk about the NFT API from Infura. Um, so basically, we created the NFT API to allow organizations to access the power of NFTs and Web3 without necessarily needing that specialized Web3 skill set. So to integrate NFTs in a crypto native way, you would need a development team that has smart contract development skills, including Solidity and Truffle and security auditing. You need this whole specialized skill set. So with that NFT API, you could leverage your existing team's skill set, like their Web 2 skill set, and just call REST API. Especially if you only have a read only use case, the NFT API will allow you just to read information about NFTs and metadata. But it also exposes information or functionality for minting and other features as well. And an SDK, a standard developer kit, is just a wrapper around API that allows you to access that API in a standardized way.
Yeah, yeah. So, I guess you said without this, we would have to have, like, a full team. Like, I guess what is the way you would, like, query for all the NFTs a user owns right now, not using the
Oh,
API?
yeah, yeah. So I mean, like, without using the NFT API?
Right. This is a leading
Uh,
question, right?
yeah, yeah.
Yeah. Yeah, because my understanding was basically, like, there's really not a good way of getting every single NFT like Chris Anatolio owns without having to look at the entire history of Ethereum or, like, do it quickly either, right? So, the popular way to do it and, I mean, I think this is also from my understanding of talking with, like, other people who do, like, NFT aggregation, so, like, our competitors, like OpenSea, as well
Sure.
as you build a separate indexer. Right? So that indexer will query all of the NFTs, and then bring it into the indexer. So then when you call actually to retrieve NFTs, you're reading from that index. You're not reading from like the entire like Ethereum chain, right? And so that's an update thing. And I think, that's what our API does as well, right? So it enables you to get NFT information quickly and efficiently. um, yeah, that's my understanding. Please correct me if I'm wrong
No, no, no.
anywhere.
No, yeah, you're totally on point there. Like, yeah, the NFT API allows you just to make a single API call and be like, give me every NFT owned by this wallet address instead of having to jump through all these hoops, interacting directly with the Ethereum JSON RPC.
Right, 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 yeah. Um, and then I guess to dive into the next point and talk a little bit about the tech tools that we'll be using as well as IPFS, right? So I don't know if you wanna give, like, a brief, what do you call it? A brief rundown on, like, IPFS first, and then we'll dive into, like, how Infura is integrating with it.
Yeah, sure. So IPFS is the interplanetary file system, so they're definitely future proofed for when Elon sends some people to Mars, we could use the same file system. But, but that's great. Um, but I mean, basically just think of like S3 from like Amazon Web Services, like you basically have a bucket, you drop a file in it, and now you have access to it, publicly on the internet. So if you take that concept and you make it decentralized and distributed, um, and make it Web 3E, uh,
Web 3E. Web 3 S3, is that what you think?
oh yeah,
Yeah.
yeah, that's catchy. Yeah, yeah, but like basically, like you have an NFT, and your NFT is connected to an animation or an image and some metadata, and you want to store that data in a way that's not centralized. Then you can throw it onto IPFS.
Right, right. Okay, cool. And then so the Infura IPFS connection comes how?
So IPFS is well, it's like a network of nodes that stores your file, but it's also like a protocol. So like when you go to a browser, you're using the HTTP protocol to like access, like an image on Dropbox or S3. Um, you can also access a image pinned on IPFS using what's called a content identifier or a CID. And natively, you access that by using IPFS as a protocol, so like colon slash slash, and then the content ID. But like Chrome, for instance, doesn't know how to resolve that. Like certain technologies do, like in Brave, if you put in an IPFS address, it'll know how
Mm.
to resolve it. Or if your website uses Cloudflare, it'll know how to resolve that image. But um, in other cases, you're going to need what's called a dedicated gateway. So basically, it's just an inferior web server that allows you to access an IPFS resource via the web, via a just standard HTTP call. Does
Oh,
that make
okay.
sense?
That
Yeah.
makes sense. Yeah, yeah. Okay, cool. So when we go through the actual code, I guess I could demonstrate what you mean by like IPFS colon
Yeah.
slash slash. Yeah. So I
Yeah.
mean, if
Yeah.
you want to
Totally.
hang around for that too, I was gonna let you leave once I start building, but I kind of want to keep you in now.
Yeah.
But
No, I'll hang out for
you'll
emotional
hang out?
support.
Yeah.
Yeah.
Thank you. Thank you. I definitely need it. But, yeah, I guess, it riffing on well, my next question is, like, what does it look like for developers not to use IPFS? But I think you had touched on that before, right? Like, otherwise, we have centralized file storage, whether that be Amazon or Azure or something like that. Then we're beholden to the big bads of the world who can just take it all down all at once, right?
And like, do you remember back in, I think it was 2017, like AWS and S3 outage? Literally it
Oh,
took down
yes, I
like half the
remember this.
internet. Yeah.
I was an intern, at a different company at the time. I was like, "Hallelujah, I cannot work today." I remember this. Yeah, yeah.
Yeah.
That was insane. Hopefully, the viewers here were around in 2017. They know what we're talking about,
Yeah.
but yeah, I forgot about that. But, and then I think I kinda wanted to just talk about since I have you here, right, we're both representatives of dev tooling, and especially as a person who's on a team, I guess, that develop, like, an API, SDK, like, all things, like, how do you see the future of blockchain development going, like, with regards to tooling? Like, what are the needs? What do you think is gonna get big? Like, I don't
Mhm.
know, open floor.
I mean, that's a big question. I
It's a
mean,
big question.
yeah. I mean, if you ask any Web3 developer, they're probably going to say like, yeah, the tooling could use some work, you know. But it's a relatively that's not like a dig against anything. It's a relatively new ecosystem. If you're comparing Web3 to, you know, web technologies that have been around since the '90s, then they're going to have a more mature like tool chain, you know. Um,
Mhm.
but yeah, so I guess like from a Web 2 perspective, you have like all this tooling that supports you from development through testing through continuous integration and deployment, and all these like static analysis tools for like
Mhm.
making sure your code or scanning your code automatically for like best practices and style and security analysis.
Yeah,
I think, yeah, we have a long way to go.
it's
Just,
a
you know,
wide range of that. Yeah, it's funny because, so I missed you in Lisbon, unfortunately. You weren't there, right? Were you in
no, no,
Lisbon?
I
No, no, no,
wasn't
no.
there.
Yeah, so I was in Lisbon. I was on a developer tooling panel, and, that was kind of the question they asked us, and I thought it was really interesting. Um, and I thought it was funny because my answer was actually like, I think the future of tooling is gonna be more SDKs and APIs. Because in a sense, I think the more we can abstract away from having to do like smart contract development, right? Like the most common use cases are like NFT interactions, like NFT subscriptions, stuff like that. Um, you don't need like the same person writing the same contract over and over and over again, right? Or like different people writing the same basic functionality over and over and over again. So it was like SDKs definitely like if you're familiar with like the low code industry right now in Web 2. You know what I'm talking about?
Yeah,
Right?
like
So for those of
stuff.
you who don't know low code, it's like this subsector, I guess, where it's focused on, again, abstracting away from the base tech to making like more friendly ways to build websites and apps and stuff like that. So you can think of like Squarespace, I would probably define as low code. It can get a little bit more intense for like government institutions, but this idea of almost like making developers obsolete is something I carry forward, and I'm like, "Ah, that's kind of cannibalizing my product, Truffle, because there's smart contract development." But I definitely think, like, yeah, working with the, like, SDK is so much simpler than, like, going through the process of, like, deploying a contract and everything. Well, actually, to that point, do you know how gas works with the SDK? Just, like, off the top of my head, I was wondering because you are like, the
Uh,
SDK includes a minting portion, right?
I'm actually not sure off the top of my head. So like minting for mainnet.
Yeah.
Uh, yeah, I might have to get back to you on that one. Actually, yeah,
Okay, cool. So
yeah.
we will, I'll update a note, I guess. I think my feeling like it was not or does take gas. It has to, right? Because part of the parameters of creating the SDK object is you pass in your wallet key. Um,
Okay, so you need
so
to have
my
like
guess is
yeah.
that it would. Um, so that seems normal. Or can you like pass it on, like the minting fee to whoever's minting it? Oh, maybe that's where it goes? But the contract deployment, sorry, I'm just talking through my thought processes here.
Okay.
Um, you're definitely giving me, like, the "What?" like, look. But, yeah, I mean, that's fine, let's actually get into the building portion. I brought on Cliff today, so Cliff, here you go. So
Hey,
like I
Cliff.
said, this is Rental Marketplace Part 2. This is Cliff. He is our front-end developer at Truffle Suite. If you've followed along with us and used things like Truffle Dashboard, for example, Cliff's like the mastermind behind putting it in dark mode. I mean, that I'm like reducing you to like only changing the code. You've definitely done way more than that. It's just like the shiniest piece. Like transaction simulations. That's what you're working on right now,
Yep.
right? That's super sexy. Um, but I guess to start over, right? Episode 2, we built a um rentable smart contract together. Episode 4, I believe, is when we actually built the marketplace contract together to do all the listing, the renting, the unlisting interactions. And now it's our final installation. And we wrapped it all in a very beautiful front end that Cliff helped to build. So, the way I'm going to handle this time is I'm going to take you through the code and explain what I understand. And in typical fashion, I will do something incorrectly, and Cliff will make fun of me and then graciously teach us a little bit more about what's going on. So, let me share my screen. Um, Here we go. So I guess before we get started, like I said, we are using the NFT API to query for all the NFTs, as well as use a dedicated gateway from Infura for IPFS to do like the image metadata retrieval. So to do that, I'm assuming you've created a Infura login. And it's very simple. You would just create a new key. So let's just say this demo. And you would copy this API key, as well as you will need this API secret. Um, that's the information you'll need to save off. I'm just going to go ahead and delete this actually because I'm exposing this to the public. How do I delete this? Security settings. Delete. Cool. And same thing right here, right? So creating an IPFS project. This is a demo. So IPFS, you'll also need this API secret. Or actually, no, you don't. Correct me if I'm wrong, Chris. For the IPFS gateway, you need the ID and the secret if you're trying to write to IPFS. But if you're just reading from it, you don't need these two pieces.
Yeah, no, it's not authenticated. Yeah, so
Yeah.
you just
Cool.
well,
But
yeah, for a retrieval operation.
yeah. Yeah. Okay, cool. And then we need to enable a dedicated gateway. So this is unique, right? So like I did this one before. And this will be taken. So you need to do something like special. So you can't do that. Anyways, so that's the information you need to set up on the Infura side. I'm going to go ahead and delete this project so you cannot use those API keys. And then move into the actual code. So let's talk about what we had from before. So the state of the world after episode 4 was we had, let me delete this. The truffle contracts that we had written. So the marketplace one and the rentable NFT one, we deployed it, wrote test, etc. And we had started off using the React box. So the React box was actually also built by Cliff, which was super cool. But now that we need to incorporate the NFT API, we had to make some changes. I asked you to explain this to me, Cliff, before. I don't think I quite understood it. So just to, or let me continue sharing my screen. Sorry, let me rephrase. To make my understanding clear, React right now, Create React app does not work with the NFT API because
So like I think it would work with the API because it would work like any other request you would just fetch. But
okay.
For the Infura SDK,
Okay.
if you were to install it as part of like on top of the Bootstrap that Create React app gives you, since React Script, the most recent version uses Webpack 5, which does not polyfill for you automatically, and you need polyfills for Infura SDK to run in the browser. So for this setup, I had to strip out React Script and put in Webpack and my own like Babel configuration for it to run.
Okay.
Oh,
cool.
just that easy. Yeah.
Yeah. Yeah. I think, and I had talked to the SDK team. I think this is not a necessary step in the next 2 weeks. So, I forgot to mention the NFT SDK API we are using is still in private beta. So you'll have to actually request access. I don't remember what the link is. Do you have it off the top of your?
Oh yeah.
Here we go.
Got it.
Yeah, sign up. So it is in beta, and so there's these little things of like why I'm like, oh yeah, this isn't this isn't in the best shape. But we're demonstrating how it works, right? So anyways, this is where it was before, and after all of Cliff's beautiful changes, it metamorphoses into all of this. So just to show, I guess, what it was before, I didn't clarify. We have kind of the basic state of the world. So there's just this ETH provider, which, okay, I need to word this correctly too, Cliff, provides like information or the context for the rest of the dApp to consume. For the base React app, the only thing that the React app needed was basically your wallet and network information, which is why we only had ETH context here. But now when we switch to the front end, we've actually fleshed out the context folder with more context because there are now more information that we need to pass around. Also, Cliff, just like interject whenever I say something wrong or you need to correct me. Like otherwise, I'm just gonna full steam ahead because I can't see your faces on my screen.
No, that was the idea of it, right? So like there was actually some changes because the ETH provider, the ETH context also exists in the React box, and this is like building on top of it a little bit to include multiple contracts. And I think that's it for this context. And then the other context, like inferior context, that's to provide to the rest of the app that one inferior SDK instance. And in the marketplace context, that's like a lot of helper methods to, for example, update the listings, update what NFTs you actually own, and like NFTs that you have rented. So things like that. And like all of these contexts, their providers wrap the entire app at like close to the root of the app, so that anywhere in the app you can just use the context and then get the value and use the value that way. So like it's worth mentioning that like the alternative, like there are different ways, like in React there are many ways to do state management, but like one alternative to using all these contexts is to use React state, to use state, and to pass each of those values down. And like, so those values in React are like, when you pass values between components, it's called props. And the problem with passing props too much is that you end up like, for example, if there's a, like for example, these contract values, if you want to pass them down, say like there's a component nested like 10 levels deep, then you need to pass it through all those components for that 10th component to get the value. But with context, you can just say you need the context, and then that component just gets the value. So that's the reasoning behind, or the logic behind like these contexts that exist.
Wow, that is amazing. See, you know, the reason I hate working with React or all of that because is I use like state and props like 10 levels down. So this has clarified a lot of stuff. So yeah, before I actually dive into code, just want to caveat, I'm not here to explain like how to write JavaScript. I'm gonna pull out the pieces that are relevant to like interacting with our smart contracts through the front end. Kind of like step by step. And I'm not monitoring the chat right now. If someone wants to do that and like tell me if anyone like asks a question as I'm like stepping through the file, please
Sure.
let me know. Just like interrupt me. I'm gonna ask you guys to be my Christmas helpers or Santa helpers. I don't know what the idiom is, but you get what I mean. So basically, I guess starting from the top, the important pieces to care about are basically in order to interact with the blockchain, we're using a library called Web3.js. The alternative you can also use as well that Truffle works with, as well as like our front end, right, is Ethers.js. So you've probably heard both of them. We chose to use Web3.js in this case. Moving in, so I guess this is just where we're initializing kind of all the artifacts or context variables we need to pass it around. So if you look here, the things that we care about are going to be that Web3 instance. So we're going to be pulling that throughout the code because we need to interact with Web3. That is created here. Basically, you just create a new Web3 instance, either with given provider. So web3.givenProvider is going to detect the current network. Is that correct, Cliff?
The given provider, yeah. So like if it was, for example, when this is running in the browser environment, I believe that given provider will map to window.ethereum, which is what MetaMask injects into the browser.
Right. So that's a really good point, I think, to call out. The way we are interacting and like getting information about the provider, the wallet account, is through the MetaMask API, right? Which is injected at what we call window.ethereum, as you mentioned. And I think, is it here anywhere? Yeah, here. I'll talk about it when we actually get to it. But anyways, that's, I guess, how you create this Web3 instance to start like actually interacting with our smart contracts. The other piece is just web3.eth.request accounts. This is how you get the ID. And then this last piece, I guess, so artifacts is created here. We only have 2 contracts we built or created that we care about. It's going to be rentable, NFT, and marketplace, right? So I guess this is just stepping through the list of artifacts. So those two
Wait,
contracts.
Emily,
Yes. Yes.
why do we need the artifacts?
Why do we need artifacts?
What are like?
Oh, is this a question from the?
Yeah, no. I'm just like asking because like for someone who if they're not familiar with Truffle, they might not know like the artifact building process and using artifacts.
Right. Okay. So, gosh darn it. So, okay, let's start over. Yes, Truffle, when we build our contracts, right? I guess if you weren't with us before, we had to specify specifically contracts build directory. So essentially, when Truffle builds the contracts, it compiles it down into a list, a bunch of JSON files. So let me see if I can find the contracts here. Right. And so this is, let's pull up one that's going to be relevant to us, rentable NFT. It's pretty long, but basically what this does is it compiles it down to a JSON that contains this idea of an ABI. So that is application binary interface. And that is essentially how we represent what functions and what are their inputs on the contract, and the second piece is like what networks and what are the addresses it's been deployed to. So to kind of demonstrate how this maps out, so if we look at something like rentable NFT, and we checked out this contract, right? I guess there's this function called mint. Oh, I didn't npm install any of these things. But anyways, mint. So if we go to rentable NFT in our ABI, there is a, I guess, like compiled down version of this function. It's named mint. The inputs were token URI, right here, and string and stuff like that. And so basically now we have this artifact that's been created of the rentable NFT contract so that our front end can understand basically how, and Web3 in coupling with Web3.js can now call the appropriate functions as well as identify the address network. So if you look at networks, this is actually all the times that I deployed the contract. So every time you deploy, if it's a new network ID, it'll bring up a new, I guess, like one of these. If it's a redeployment, it will replace the address. So this is the contract address. Is that clear? Did I explain that correctly?
That was very good.
Okay. Thank you, Cliff. Wow, you made my heart beat. I was so scared. Like, I'm not good at doing things on the fly. Cool. So where did I go? Back to ETH provider. Cool. So artifacts, as you mentioned, are our JSON files that Truffle breaks our contracts down to for Web3 to communicate with or understand. And I'm guessing my understanding is here is we're just creating contracts, like the contracts variable to interact with later. So the things that we care about specifically is the actual contract abstraction, which is created by calling Web3 ETH contract and then adding in the ABI, which I mentioned is the application binary interface, as well as the address of the contract that is relevant to the current network ID that your window is on. So that's what this does. And then I think the last piece that we care about that's interesting here is going to be detecting updates, right? So if you interacted with a dApp before, the user has the ability to essentially go into their MetaMask wallet and change out their networks from like Gurley to mainnet to a local host, etc. Like, how do we actually figure that out? Or like, how does that happen? So this part is where we actually do the handle detection. Window Ethereum, like I mentioned, is injected by the MetaMask API. So this is how we interact with that information. Specifically, there's two parts to it. So Window Ethereum on, it's a listener. We care about things like the chain changing. So that's like the network changing. And then accounts changing. So that's changing from like account 1 to an account 2. And these are defined by the MetaMask API. So that's where these values come from. Right. And then the second piece is it just like after you detect a change, you have to remove the listener?
Oh, so this is a React specific thing inside
Okay.
use effect. If you like if you are instantiating an event listener inside use effect, which is what we're doing here because we're doing window.ethereum.on.
Okay.
We want to make sure that when the component unmounts or like when it re-renders, that the listener is removed, because otherwise, if it just keeps unmounting and mounting, and the event listener from the previous like before it was unmounted, it would still be there. So, and it would never get garbage collected, and you'll run into memory management issues. So this is, yeah.
I see. Okay, cool. So I think that is everything I thought was important in ETH provider. Do you have anything you want to add? Or we can
No, that
move
was
on.
good. Like it just gets it provides to the rest of the app all the smart contract related things.
Right. Cool. So then now we have Infura Context. So this is what you were saying is like provides the SDK, right? So for those of you who have never used the Infura SDK before, it's a NPM package. Whoops. So you would just do, it's already part of this code. So if you just do an npm I, it's there. But you would just do an npm I at Infura SDK. And in order to use the SDK, you need to provide it an auth object, so authentication. So that's what I was talking about at the very beginning when I was saying, like, go into Infura, create a project, and create an IPFS. The way we do that is get these auth options. So one thing you need to do actually during the setup portion, I'm not going to actually show you the real JSON because that has my private key, but what it requires you to do is essentially pass in information that you care about. So it's going to be your project ID that I had mentioned before, the secret, and then private key. So it's going to be your wallet's private key. I don't think I've actually ever mentioned this before, but like word to the wise, if you're doing development, you should actually also have a separate wallet only for development that doesn't include any mainnet ETH or whatever. Um, so that, you know, in the worst case scenario, you accidentally live stream your public private key or you publish it somewhere. At least it's just your girly ETH that was lost, right? And not your life savings. And then the other piece is the IPFS subdomain. So if you remember before, I had included, I had called my gateway like rental marketplace. This is going to be replaced with rental marketplace, not the full gateway. So you might also see in your view, you might have like a rental marketplace like IPFS. I forget what that is, but we're not putting the full URL, just the subdomain. If that's unclear to people. But anyways, that is information we need to do there. We also need to pass in the chain ID we care about. In this case, we just, I guess the default is 5 because like we're just doing test nets and it's girly. I guess the assumption is if you were to take this into like the real world, you would probably want to, I guess, modify auth options also dependent on whatever the ETH provider is providing, right, in terms of network ID. Is that correct, Cliff?
Yeah.
Yeah. Okay, cool. So that's the auth object. And then moving forward, actually using SDKs, relatively simple. This is how you instantiate it. You literally just say like new SDK auth. And the next piece here is, I guess this is an example of how we are using the ETH provider, right? It's just calling use ETH. And in this case, the only thing we care about from the artifacts or what it provides is the contracts in this case. So example. Anyways, moving on, I guess the most important thing here for Infura Context is actually getting the rentable NFTs so that you own. So as part of the step, you want to be able to view essentially what NFTs you own, but also the NFTs that are rentable. So essentially allowing you to go onto the app and list your NFTs, put them up for rent. In order to do that, there's, I guess we do this in 2 ways, right? So first off, actually getting the NFT. So this is the meat of it, right? This is just calling the API. You just pass in the appropriate address. So in this case, public address, this is a function, so it's whatever I guess that address would be. In actual practice that we're using it, it's the account that you're currently on, because that's how you're viewing the web page. And then including the metadata, that's just a true. And the second piece right here, so this is actually the first time that we're going to be I'll be talking about how we interact with our smart contract function, right? So if you guys remember from our previous episode, there we go. Is rentable NFT is a function that we wrote that essentially detects two things. First off, if it supports 4907, so that's the rentable NFT standard, as well as 721, which indicates that it's an NFT. So if either of these two, what do you call it? Either of these two properties are false, then this will return false. And just to call it, basically contracts.marketplace. So this is the marketplace contract abstraction that we had created before. So just heading back to ETH provider, just so you can see it again, right here, we just called it new Web3 ETH contract, and it would pass in the marketplace ABI, which includes, let me just show this to you so it's in case it wasn't clear already. That's fine, is rentable NFT. Includes this here, so that's how it finds it from the ABI, the marketplace API. So going back to here, this is our contract abstraction, diving into methods, and then finding rentable NFT, asset.contract. So this is the contract contract address, right? So when we return, when get NFTs returns like a bunch of, I guess, NFTs is what it would look like. To get that address, you would just call asset.contract. And then because this is calling a function, it's a dot call. To clarify that even further, if you're like when we talk about smart contract functions, it's like read and writes, right? So reads don't alter contract state. You would call these functions using call. Writes, where you do modify contract state, or you're going to be calling using a send. And we'll get into an example of that later, but just want to clarify there. And the last piece, I guess, is that it returns basically the filtered NFTs. So only the ones that are NFTs and are rentable, owned by you. And that's Infura context. Cool. Moving on, I guess. Now we have marketplace context. So marketplace is actually going to be the part where we are going to be doing all the actual interactions, right? So this is the code that contains the listing, the unlisting, the renting, minting, and updates. So I guess starting from the top again, if you note here, right, so we're using ETH, so we're getting that Ethereum context, the wallet, the network ID, etc. We've now also added use Infura, right? So now we're taking advantage of the Infura context that we had before. So specifically that function to get the SDK and use it to call the NFT API and retrieve rentable NFTs is how we're going to be interacting with it here. And then this other piece actually is IPFS gateway URI. It's from a utilities. We'll actually dive into the meat of that later because I'm just going to go down one by one. But you can just imagine it as getting the appropriate IPFS metadata using the Infura gateway. That's just how we get the correct string. And then from that string, we can resolve that to an image. So yeah, that's the stuff that's important at the top. Otherwise, we can move on. So this function is meaty, but it's not. It's intimidating. It's not that intimidating. Don't be too scared. Update listings. So update listings is basically, I think what it sounds like, right? So basically, anytime a listing, I guess, is going to be changing information. So for example, it's being rented, the time is, or like being unlisted, etc., that like modifies a NFT listings property. So I guess update listings is what it does to essentially convert all of the properties into, I don't know. I'm explaining this very poorly. Cliff, do you want to take a stab?
Yeah, sure.
Yeah.
So the gist of it is that like the marketplace contract has this very helpful method to like right there, marketplace contract.methods get all listings, right? But what you get back is we need to transform it somehow for all the React components that we build to consume it. And I don't remember specifically what we're doing here. Oh, so for example, if you go on, if you see line 42, like the get all listings method doesn't give you, for example, the actual IPFS address that points to the image or to the video of that NFT. So we need to take what the method gives back to us and then process it. So for example, here we are getting the actual IPFS media URI, and then like it's all of the stuff together, and then you put it into a list, and then the rest of the app can use this information to display all the listings.
I see.
Yeah.
So I guess the transform data part is because when you retrieve get all listings, all of that data, so like price, time, etc., is actually all coming back as a string, right?
Yeah,
as well.
yeah.
But then we need to actually change it into the correct type that we're expecting.
Exactly. So like any like there's a bunch of different properties associated with each listing. We want to pre-process it so that the rest of the app can so the rest of the app can just say like, oh, this is a value and it's the type that I expected, and I can just display it, as opposed to doing more processing on the component level.
Cool. And then I guess I have a question for you. I didn't notice this. Can you just make this? Is there a specific reason? Oh, is this because? Sorry, I don't even know. Can we not use artifacts here? Oh.
You mean the like the rentable NFT contract? Is that?
Yeah.
So the reason we can't reuse that is because we want to like not every
Right.
listing is minted from the same rentable NFT contract.
I see. Okay, that makes sense. So actually, Cliff, the correct way to do that would be 4907. Oh wait, no. Just kidding. I'm confusing myself. You're right. Okay, cool. That makes sense. So I guess
Wait, actually, I think you're right. Like
no. I'm wrong. Okay, because 4907 only represents the rentable part. NFT is represented by the 721 part. So I created this like interface contract. So it's not an interface contract, but this contract rentable NFT to represent anything that is both a rentable and it's an NFT. And that's what we're expecting from this address. I think that's why it's correct.
Is 4907 sorry, I'm not too familiar with it. Is it like rentable but not specific to NFTs?
Right. So it's called the Universal Rentable Standard. So you could use it in the sense that well actually, so in case really you don't even have to do this. You could just do this actually, I think. Right? Because the only thing that we cared about from NFT contract, at least in this method right here, is token URI. So token URI is a method that is specific to the 721, so the NFTs, right? But if you were doing something like I wanted to check the expiration date, you would have to use IRC 4907 because that's associated with rentability, but not NFTs. But in this case, we are combining the two through the rentable NFT contract. Yeah. So does that make sense?
Oh, you can see me. Yeah, I gave you thumbs up.
Oh, okay, cool. I can't see you. Okay, cool. So this is just, I guess, getting the data. I don't know what this is. Was it just commented on?
I guess I think that property became redundant because if there's no user that's currently renting it, it'll be 0x000, and then when you parse it, it'll be 0. But I think
I see.
we do that somewhere else. It's okay.
It's okay. Cool. Next piece is update owned tokens. So this is essentially because we are renting, doing stuff with our tokens. I guess this is just to update the state of it, right? In which case we have two formats that we care about. So if infura.active, so I didn't mention this actually in the example JSON, there is this additional property called active. So if it's active, that means we're on a test net. We're not using Ganache. Our intention is to query using the NFT API, right? If it's false, then we will be doing it in a different way. So I don't remember where it was. Marketplace, I was back here. Right, so the first one is just using the NFT SDK. So this is just calling get own rentable NFTs that we had talked about before. And then I guess transforming that and adding it as your own tokens with the new information. Otherwise, if we're not, we're using a local network called Ganache. And the important piece here, I guess, is instead of just retrieving. So if you remember, actually, in the beginning of this podcast, I don't know what you call it, right? I asked, what's the alternative if we don't have an API, right? It's actually we have to query the history of the blockchain. And so this is actually an example of how it was done, basically getting all the past events associated with this contract. Specifically, the way NFT mints work is that a transfer event is emitted. And that is how we're just checking whether or not, like which ones you own, right? So this is a very manual process. It's also very specific to like this contract, and is why we need an API.
I think there are many ways in which the Infura SDK provides like, you know, a better way of doing this, because like, for example, this mint event, that from filter will actually cause it to only look for NFTs that were minted, but if you were to transfer them, it wouldn't get the data correctly. And like there are other issues, right? So like there are other improvements that the Infura SDK can give you. For example, like doing it this way by getting the events, it would work most of the time. But say, for example, if you're in a real world app, you might get like rate limited because you have a bunch of users all doing the same query, and the Infura SDK is a way around that to so that you can properly monitor and manage your app.
Yes, nice. A+. Okay, cool. I talked really slowly. Somehow all the time ran away. So I'll speed up. Mint is just minting. So this is where I started. Are you guys getting feedback, or am I just hearing myself? Is there any echo
Not
for you
really.
guys?
No.
Okay, whatever. I'll just deal with it. Okay, cool. Mint. So if you guys remember, I was talking about call versus send. This is actually an example now of when we are altering contract state. So we're minting an NFT, and we're actually hitting the send. We're passing in who is calling the send, and that's from account 0. So account 0 represents the, I guess, account you're currently on. Two things to note here. The SDK does allow you to do minting. So we could have, or in a vanilla case, I guess we could have just called like the SDK.mint function, and we wouldn't have needed to even write a smart contract in the first place. However, in this case, because we were writing rentable NFT contracts, that template is not yet supported by the Infura SDK. So it is expanded functionality on top of it. So that's why we had to write a custom mint function and contract. But I expect in the future, like once Infura is out of the beta phase and continuing to flesh out its SDK, you'll make my job obsolete. Anyways, okay, moving forward, list is just listing. So I'm not going to talk about these too extensively because a lot of it is just like figuring out the math behind like the times and the value transfer. But again, we're talking about list NFT. I guess I do want to call out specifically, who's the one listing it. It's me. I'm the current user. We add this new parameter called value. So value is the amount that needs to be sent. In this case, if you guys remember from Marketplace with list NFT, we actually need to pass in a listing fee because it costs money for you to put up your rental, your listing. And so that's why we pass in this value. The second piece here is unlist. Also, nothing exciting. It's just a bunch of math because if you remember when we talked about unlisting the NFT, the owner of the NFT actually has to pay a penalty if they are unlisting an NFT that is being rented currently by someone else, like so breaking a contract, for example. And that's all of this stuff, but otherwise just sending in, I guess, the refund and the accounts. And then rent. So again, same thing, rent. We're just sending options, which is who it's coming from. So that's the current account and the fee. And so that's everything in marketplace context. And the last piece, time context doesn't really have to do anything with, I guess, the blockchain. This is just beautiful, like UI stuff, is my understanding. When we dive into actually what the UI looks like, time context essentially allows us to get a specific time to be displayed. I'm not explaining this well because it's hard to explain if you don't actually see it. So I'm actually just going to get into the demo portion. Where are we? Okay, cool. So all I need to do is an npm start. Oh, I guess I'm starting from the beginning, right? So technically, if you haven't, if you're starting from this from scratch, right, you should have done an npm I of truffle as well within this folder. And you need to deploy your contracts to actually be used by truffle. So to do that, I'm just going to use dashboard, which Cliff helped to build. So this is what it looks like. If you guys have been with us, you've seen it for a while. And then I'll go into truffle again, and then truffle migrate network dashboard. So once this goes through, I'm actually going to reject all of these transactions because Girly ETH is in short supply, and I have already deployed these. But imagine like that's what it would look like. It would have been deployed, and it would have shown up in the JSON like ABI thing that we had provided. But as you can see, it's already there since I did this beforehand. Anyways, I think that's all you need to get started. And so I actually also already have it running, I guess, but I'll just do it again. npm start. So if we go to localhost 3k, this is what it looks like. This is just, I guess we're on the default market. Nothing has been listed. Checking which account we're on. We're on Girly test. So owned NFTs. So this is actually doing the filter. All of these guys are from when I was just testing this out and put in nonsense IPFS URIs. So that's why there's no images here. But this is from just pasting in IPFS metadata from the Doodles collection. And Cliff got it off of OpenSea, if I remember correctly. Yeah. So these are filtered. I actually have a lot more NFTs on Girly, but you don't see them here because we checked it using isRentable NFTs. But anyways, so all you need to do just to show that this is a fully working dApp, let's say the duration is 5 days. The price is 1 Gwei. I'm going to list it. So as you can see here, it was accepting that listing fee, and then I have to pay some gas to list it. I'm going to hit confirm. If I go to the market, it will take some time because there's some Girly. Why am I doing this with real money? Or fake real money. Okay, cool. So now here's this. There's some like, I guess, built-in stuff. So if you want to actually try like renting it, you can change accounts. Oh no, it's not switching accounts. Here. And now we can rent it. Rent. And it's so cheap to rent that it looks like 0 Girly ETH. It costs more gas to rent it than to actually pay. And so that is going to take a hot sec. as we're interacting. And then we'll see. I guess side plug, if we had verified these contracts, which I showed you how to do, I think in episode 4, all of these would actually have the real like name. But anyways, if we go to rented NFTs, now it's here and we can see it with all the beautiful information. And then this is, why is this not? Oh, because I'm on the wrong account. Okay. So if I go back to account 1 and I see this, you can see that. Can you see that it's been listed?
I don't know why it's not refreshing. Try just refreshing. Oh, it should say that you're unable to list it. I think right now, if you try to list it again, it will, the transaction will revert. But actually, if you go on the market, maybe it'll say.
It says you're the owner.
Oh.
Well, I mean, that's fine. That's just like a cosmetic thing. We're here to learn about how to build the front end, not how to catch edge cases. What do you think? Who do you think we are? Yeah, so anyways, now that you've seen what all this looks like, I think it'll probably be easier to explain the rest of the code, which is essentially, we don't actually need to dive into it that much, but just like formatting, right? So this is like the card that will get the information. And so like I guess this is how this is made, right? All of this like table, list, price, progress, all of that is shown here. And then under these folders right here, so market, owned, rented, represent each of these tabs. So that just controls the structure of how it looks. And then, oh, I did say I was going to touch upon this very quickly. So utility functions, I guess this is just a enumeration, enum. I don't know what you call it in JavaScript, but yeah, mapping a state to a number. But essentially, the piece here that we care about, right, is we plugged in this subdomain that we had put in from our environment.json. This is our dedicated gateway. And then basically, this is just doing I guess regex matching, because like what it passed in, and this is just like I'm just typing this in, right, would look something like IPFS, like blah, 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 right? So then what this actually makes it happen, the result looks something like, I guess it would look like and then take this guy and put it here, and that is the resolved gateway URI, right? That's what this code is doing. Yes.
Yeah, oh my god, I keep forgetting that you can't see. Yes, like
yeah, sorry, I can't see you. No worries. Yeah. My life is full of awkward pauses where people don't care about me. Cliff. No, I'm just kidding. Okay, I think that's everything. That is, I thought was of note. Do you have anything else you want to add or embellish upon, Cliff?
I don't think so. Yeah, I mean, I think you covered it pretty well.
Okay, awesome. Cool. I'm going to stop sharing my screen. Hack back in. Is there anything else? I don't know. Chris, do you have any questions? Anything you want to say? Someone said this was pretty neat. Thank you. It is pretty neat. If you guys don't have anything, I guess I'll just talk a little bit about what's coming up next. So next week, we're going to be talking with Harsh, the founder of Push Protocol. So if you guys don't know Push Protocol, or Push, I guess it was formerly Ethereum push notification service. Now Push, because it is cross-chain. So if you ever had questions about how do I do like cross-chain messaging or Web3 communication in general, how do I have a dApp send out notifications based on on-chain and off-chain data? If those questions plague you at night, first off, I think you're super cool. Second off, join us next week and we'll be talking with Harsh about that. So yeah. if there's not any questions, I know there's always some lag, so I'll count down from 5. And if everything ends at 5, then I'll say goodbye. And thank you so much, Cliff and Chris, for joining.
Yeah,
So
thanks for having us.
5, 4, 3, 2,
Wait.
1. Okay. No! Dude, man. Yeah, okay, that's gonna be the clip I clip out for our social media. This is what you'll learn. Okay, cool. This is awkward. Bye. I'm gonna end the stream.
Bye.